Yeah, you guys online might want to do that also. NYC data reduced set, you might want to open that now that you have the opportunity in a separate window if you want to make the window a little bit smaller or something like that. So maybe you can find a way where you can watch what I'm doing at the same time that you can actually maybe try this on your own. Here in class, if you had taken the subway in and joined us here in class, you'd have your own computers and you can watch me do it on the big screen behind us. In the meantime, I also want to fix this so it doesn't keep blanking out on us. Energy. Okay, we should be better off now. Okay, so I'm going to give you another minute to open up the data file. Uh, NYC data, reduce set. It's on Blackboard. I'm sorry? No, no. And it's under, oh, I'm sorry. It's under lab session, sections 003 and 004. This one's the same one? Okay. Oh, yeah. Then one of the variables is flu vaccine. Okay. All right. So I'm going to get started. Okay. I'm going to get started. Okay. So I have this data file open behind me. Unfortunately, there's no easy way for me to just under view. It doesn't let you zoom and stuff like that in SPSS. So I can't really kind of blow this up. So it's a little bit small. So you'll notice that I scaled it down to a certain number of variables. I also cut down on the size of the data file. Now, some of these variables may be variables you're going to use on your own. Now, keep in mind that I only cut it down to 2,000 of the 8,000 or 10,000 people that they surveyed. So you're not going to be able to use this data set, or what I'm going to do here is not going to be very useful to you when you actually do your project. So don't steal what I'm doing for your projects, because you'll be in a lot of trouble then, because it's not the full data set. Okay, I did that on purpose so I could use this. Okay, but you'll get the idea from this. Okay, all right. So now let's take a look at what these variables are. When you yeah. Okay. So I'm looking at these variables now. I'm going to go to the variable view and I'm going to take a look at which variables I kept. Let's see, mood. I'm gonna open this. I'm gonna open up the label so we can see what the question was a little bit better. Okay. Was there a month past 12 months that you were depressed? And the answers could be, if you look into the values, the answers could be yes and no. Have you ever even once used a needle to inject a drug that was not prescribed? That was a yes and no answer. What kind of variables are these? They're categorical variables, right? Nominal or categorical variables, yes and no's. Some of them categorical variables that have more than two results. For instance, self-reported health status: 1 excellent, 2 very good, 3 good, 4 fair, 5 poor. Right? They're not just not ones and twos, but they could be 1 through 5 or something like that. But still a categorical variable. These are the kind of variables that we use these kind of analyses for, because we want to set up contingency tables. right? So I'm going to start out, I'm going to pick a couple of variables here. One that I think is a good exposure and one that might be an outcome. So for instance, let's see, what do I have here? Let's see, general health status. Let's see. Okay. Have you? I'm going to use as an exposure drug use. Okay. Have you ever once used a needle to inject a drug that was not prescribed for you? Okay. Or I have another one here that's a good one. Smoking status. Okay. I'm going to use drug use first because I want to show you something about smoking status in just a little while. Okay. So let's see if IV drug users are more likely to, say, have diabetes. Okay, exposure, IV drug use, outcome in the columns. You have diabetes, you don't have diabetes. Let me just check in there. Yeah, that's just a yes or no. One is yes, two is no. Okay, so I'm going to go back to my data view. And if I look over here, this first column is drug use and diabetes. Yes or no, having diabetes is here. Now, one of the things that I can do in SPSS is I can go up here to the view and tell it to turn on the value labels. And that will automatically change the number for the what the number represents. But it's really a number behind there, just like we have over here. The values are defined here. Okay, so I'm going to go here. I'm just going to leave it that way. I can leave it turned on or turned off. It doesn't matter. I'm going to build a contingency table. It's the first thing I'm going to do. I want to organize this data. There's 2,000 people here. I can't tell just by looking, what these numbers are going to be. So I'm going to go up here to analyze. We always start off with analyze, right? I'm going to go to descriptive statistics. And under descriptive statistics, you'll see crosstabs. Another word for a contingency table, crosstabs. I'm going to click on crosstabs. So what am I putting in the rows? I'm putting the exposure. Okay. Have you ever even once used IV drugs? If you point with the arrow and hover over that choice, it'll give you the whole length of it. Okay. So I'm going to move that into the rows. Now the outcome, I'm going to move into the columns. And what was that? Diabetes, right? Let's see. Have you ever been told by a doctor and nurse? Is that the one? Hypertension. Meds. Here you go. Have you ever been told you have diabetes? I'm going to click on that one and put it into the columns. Okay, so now I am going to go into statistics. I'm not going to check anything off. I'm just showing what that looks like when you click on statistics. And I'm just going to close it. Now I'm going to go into cells. And you see what this looks like. Right now, by default, the only thing checked is observed. Right? Everybody agree? The only thing checked there is observed. I'm going to say continue, and I'm going to say OK. What's going to happen when I say OK? SPSS drops the data window behind, pulls the output window up front. It uses separate windows, and it does the calculation that we just asked it to. And the calculation was, well, tell me, have you ever used use a needle, inject drugs? And as it happens, we have, I got a problem with that data. Don't I? Wouldn't you know it? And it works with the full data set, and I screwed it up by reducing it. Okay, I'm gonna try another one. Analyze. I'm gonna try. Maybe we'll get a little bit luckier with asthma. There's not many. There's not many. I'm gonna go to smoker instead. There's not many IV drug users in this or admitted IV drug users. I'm gonna instead of using this, I can move these things back here. My exposure is going to be smoking status. I'm going to move it into the rows. My outcome, again, I'm going to try diabetes again this time since I got a feeling I'll have a better sample. I'm going to move it in here. What's that? I'm sorry. Oh, okay. That's okay. That's okay. I'll tell you. Yeah, exactly. That's why I didn't do. We're going to learn something else about SPSS right now. Good. No, I'm glad this came up. Especially for you guys that want a little bit more experience with SPSS. The problem that was just brought up was that if I look at smoker, it's not just am a smoker or not a smoker. It's that, let's look in the variable view. Okay, under smoker. It's that, okay, smoking status, instead of smoked or doesn't smoke, it says never, current, or former. I got an extra category there. Okay, I don't want that to confuse the issue. So what I'm going to do is I'm going to create a new variable from the old variable. Before I do that, I'm taking a closer look here. Never is one. I'm going to combine them into two values. Never is one. People that have smoked, either currently or formerly, are 2 and 3. Okay, so I'm going to say cancel this, and I'm going to go over here. I like working there, the data views, but you don't really have to if you don't want to. I'm going to go to the column that says transform. I'm going to click down on that. You got a lot of things here. You can compute, you can do a calculation, you can recode into the same variables. That means you can change the variable and then put it back into the same place, which erases the original variable. I don't want to do that. I'm going to recode into different variables. I'm going to click on that. A window comes up. Okay. And I'm going to say, okay, my input variable is that smoking. I'm going to take that smoking. I want to change it into a new variable. The output variable I'm going to put is, I'm going to call it ever smoked. And the label is going to be ever smoked, ever or currently smoked cigarettes. Smoke. Okay, that's what I'm going to call the label. The variable name has to start with a
Does the label only matter when it comes out in the table?
the label, the name, you're exactly right. The name is the variable name. That has to follow certain rules. You can't have unusual characters in it, can't have spaces in it, it's got to start with a letter. Okay? The label can be basically anything you want, can be more descriptive, and will be printed on tables and charts and graphs and so on and so forth when you actually do the work. Okay, so now I'm going to tell it how I'm going to transform this. I'm going to click old and new values. Well, the old value, if the old value was 1, I'm going to tell it the new value is still 1. I'm going to add that. Okay, old value was 1, meaning that they never smoked. New value is going to stay 1, right? Actually, I'm going to change. I have an idea about this. I'm going to not do that. I'm going to get rid of that. I'm going to say if the old value was 1, right, never smoked, I'm going to make the new value 2. You're going to see why I do that. You're going to see why I do that. So now 2 and 3 are smokers. I'm going to say if the old value was 2, I'm going to make the new value 1. And if the old value was 3, I'm also going to make that a 1. So now when I'm done, the people that are smokers will all have the value 1, and the people that are non-smokers will all have the value 2. Okay, and I'm going to click continue. And now I'm going to click, see a little box there. You can't click OK. The reason for that is that we haven't really changed anything yet. You got to click that little box that says I'm ready to change. And you'll notice that it says now smoker is changed to ever smoked. And you can click OK. And it goes at the output table. I'm going to click back on the original table. If you look, there's a new column there, ever smoked. And you'll notice that if you never smoked, let's see, you're a 2. Current smoker is a 1. Current smoker is a 1. Never 2. Let's see if I got a former smoker is a 1. It made the conversion for us. So now I'm going to go and do my analysis. Analyze, descriptive statistics, crosstabs. Okay, am I going too fast for you guys? Yes, I am going too fast for you guys. Okay, don't worry about it. I just needed to do that step for myself to make the contingency table I wanted to. I didn't mean for us to have to do that here, but I figured it was a chance for those of us that are a little bit more comfortable with SPSS to see that done. But don't worry about it. If you didn't get that part of it, don't worry about it. Okay, so now I'm going to put into rows smoking status, which is the new variable I created at the bottom there, ever or currently smoked. That's my rows. And in my columns, I'm going to put, how about asthma? Let's put asthma. Have you ever been told by a doctor or a nurse that you had asthma? Let's put that into columns. So that's a yes or a no outcome. Okay? So now I'm going to click into cells again. The only thing checked is observed. And I'm going to click OK. SPSS will go through all 2,000 subjects and create our contingency table. And here's our contingency table. There's out of 910 people, 123 that are smokers, 123 of them have been told they had asthma. Out of 1,078, 128 people have been told that they had asthma at one point or another. Okay, so now, and I didn't know how, what the outcome of this would be. We'll see. We'll see as we go through this. There may be association. There may not be association. I can think of reasons why there would be and why there wouldn't be. For instance, you might think smoking might induce people to have asthma attacks, right? On the other hand, if you have asthma, what are you not likely to be doing? Right. So who knows what the data is going to tell us, right? Okay. So in other words, okay. So let's take a look at this. This is what is this? Our observed table or expected values? That's our observed, right? I want to calculate my expected values. SPSS will do that for us. I'm going to go up to Analyze, Descriptive Statistics, crosstabs again. I'm going to go into that cells table. This time I'm going to check off observed and expected. And I'm going to click Continue and OK. Now SPSS has taken this data and now it's calculated expected values. So for smokers, we counted 123. We expected 115. For non-smokers, we counted 128. We expected 136, right? So there are differences here. Then our observed and our expected are different. Okay, so now I'm going to go back. For a moment, I'm going to backtrack one step. I'm going to go to Descriptive Statistics crosstabs. I'm going to go back there and I'm going to turn off expected values and do this again, just so I get back to that table I started with. Okay, there's my observed values again. Instead of going right into the expected values, I'm going to go to Analyze, Descriptive Statistics, crosstabs, and I'm going to go into Cells, and I'm going to tell it to calculate the percentages by rows. And I'm going to click Continue. And OK. What does it just calculate? It calculated the percentage of people that are smokers that have been told that they have asthma. What's your risk of having asthma if you're a smoker? What is it? 13.5%. What's your risk of having asthma if you're a non-smoker? 11.9%. What's your relative risk? It's going to be 13.5 over 11.9, right? So our relative risk looks like it's going to be about, I don't know, 1.4, 1.3, 1.4. Let's get SPSS to calculate it for us. 1.1, Descriptive Statistics, crosstabs, right? I'm going to go into statistics this time, and there's a check mark here that we can put into risk. I'm going to click that and click Continue and say, OK. OK, so now we got a new box. We got the same box before with the contingency, with our contingency table, our observed values. Odds now, our calculation was going to be, I'm going to bring up the calculator. Our relative risk was going to be equal to 13.5% divided by 11.9%, okay, which is 1.134. We see that anywhere down here? Okay, and these are rounded numbers. 13.5 and 11.9 is a rounded number. If I use the actual values here for the people, for the actual people, it would have come out exactly the same. This is your relative risk for cohort ever told by doctor that you have had asthma and asthma equals yes. It's one. The relative risk is 1.138. You're 1.138 times as likely to have asthma if you're a smoker than if you're not a smoker. That's your relative risk. What's your odds ratio? How would you calculate your odds ratio? Well, your odds ratio would be 123 divided by 784 over 128 divided by 950. I'm going to do that right now. 123 divided by 787. Okay, that's my odds of having asthma if I'm a smoker. I'm going to put that into memory. And I'm going to clear that up by Okay. Actually, I'm going to do it the other way around. I'm going to do the bottom part first. 128 divided by 950 is equal to 0.1347. I'm going to put that into memory. Let me clear memory. Whoops. Hit the wrong button. Clear memory. Clear memory. Okay. 128 divided by 950. And I'm going to put that number into memory. It's in memory now. So I'm going to clear my display. And I'm going to divide 123 by 787 divided by 787. Okay, is equal to 0.1562. And I'm going to divide that by my odds of having asthma if I'm a non-smoker, and that's equal to 1.599 or 1.60. This column, this row, is our odds ratio. Okay, SPSS gives us our odds ratio and our relative risk. Now it also calculates for us the confidence interval for the odds ratio and the relative risk. So the 95, what is our expectation for the odds ratio and the relative risk if there's no association between the two of them? 1. Okay. Our confidence interval for the real odds ratio is 0.89 to 1.5. Can I reject that null hypothesis? No, I can't, because I can't say that it's different than 1. Okay. That's how we use SPSS to calculate the odds ratio, the relative risk, and so on and so forth. Okay, now I'm going to go back and we use the same thing to calculate our chi-square value. Okay, and we can apply a different analysis to the same data. Analyze, descriptive statistics, crosstabs. This time I'm going to go into cells. I'm going to say calculate my observed and expected. I'm going to turn off percentages. Don't need them. I'm going to go into statistics and click chi-square. I'm going to turn off risks since we did that before. I'm only interested in chi-square now. So in statistics, I turned on chi-square. In cells, I turned on observed and expected. And I'm going to click OK. Let's see what SPSS gives me. SPSS gives me my observed and my expected values for this sample in this population. And it gives me my values for chi-square. Our value for chi-square that we calculated, observed minus expected squared over expected, and then add up all the 4 numbers, that's this value here, 1.02. Remember I told you about the continuity correction? You subtract 0.05 from the top before you do the rest of it and calculate it out. That's going to be a slightly smaller number. And in fact, here it is with the continuity correction applied because it's a 2x2 table. Okay, so depending on which one you use, you're going to have the same outcome, right? Because your chi-square value, 1 degree of freedom, is that bigger than your critical value? No, it's not. Critical value is 3.84 for 1 degree of freedom. That's how big our chi-square value had to be for us to reject the null hypothesis. SPSS doesn't require you to go to a table to remember the critical value. It actually gives you a probability of being wrong if you reject the null hypothesis, a p-value, probability that this would really be from the same population. Okay, and what is it for us? If we don't apply the continuity correction, it's 0.27. What does that have to be smaller than for us to be 95%? 0.05. It's not smaller than 0.05, so we fail to reject the null hypothesis. Right? The p-value, the probability of being incorrect, if we reject is not less than 0.05, we can't reject. So you don't need the table here because it actually gives you a real p-value, a real probability. It happens to call it two-sided. I vaguely remember a couple of years ago looking up why it calls it two-sided instead of one-sided. I don't remember. If anybody's really interested, I'll try and dig it up again. But there's a reason why SPSS calls it two-sided instead of one-sided. Even though kind of intuitively it seems like one-sided, right? That's a good question. It's calls it significance. Another way of the statistical significance. It's kind of like another way of saying p-value. Asymptotic, I guess that means one-sided, I guess. Maybe it just seems like a contradiction in terms. It says asymptotic significance two-sided, which seems like number one, contradiction in terms, and number two, it doesn't seem intuitive that it's two-sided. But that, I looked it up, and to be honest with you, I don't remember why they use that particular format for expressing it. Yeah, yeah, yeah. I guess they put it there so you're not tempted to then go back and double the p-value or something like that. But I'm guessing at that, but I do remember looking it up, and I found some reference to why they expressed it that way for chi-square. But I'll see if I can't find that. But just keep in mind, if it's less than 0.05, reject the null hypothesis, right? So that's where we are there. Okay, so now what I'm going to do now is we have about, I guess, about 15 minutes left. There's another data set there called stenosis, right? That has stenosis is a narrowing of arteries, right? And there's three variables there: gender, smoking status, only one or two, and there is a stenosis. Yes, they have it. No, they don't have it. So I'm going to leave it up to you now. I'm going to give you about 5 or 10 minutes to pull that down, open it up, and find an odds ratio or relative risk for whether or not there is an association between stenosis, between smoking or gender, you choose, and stenosis, and find a chi-square value for that data. Can you say, based on the data you have there, that there is or is not an association between the two? So it's on Blackboard also. It's a smaller data set. It's only got those three variables: gender, gender, smoking status, and stenosis. Let me take a quick look at the guys online. Okay, income, not much coming in from the peanut gallery here. How are things going on online? First of all, number one, who online can tell me what the peanut gallery is from? Anybody know what the peanut gallery is from? No?
Originally?
Yeah.
Well, I think there's reference to it in the Muppet Show.
Yeah. Well, yeah, there's reference to it. It was originally from a show called Howdy Doody. Okay. the kids in the audience at the Howdy Doody show used to be called the Peanut Gallery. Look that up. Google Peanut Gallery. Between smoking or gender, either one, you pick which one we want to put in the rows, and stenosis, which is basically hardening your arteries, clogging your arteries. Okay, so those are your two variables. So you saw how I did that, right? I went to analyze, opened the file, went to analyze, descriptive statistics. Then I went to, where'd I go from there? I went to crosstabs. And then I went into statistics and into the tables tab, cells tab rather, in order to decide what I wanted it to display. Whether I wanted to display risk, whether I wanted it to display chi-square value, and say you do the chi-square calculation, observed, expected, and so on and so forth. Okay. For now, for our purposes, I'm just going to ask you to do the calculation. You'll notice that on Blackboard, there's a one-page document, right? There's a one-page document there. And that one-page document has this. Where is it? Let's see. Lab exercise is called. That one-page document asks you a bunch of questions. Oop, here we go. This one-page document asks you a bunch of questions, or asks you to do a bunch of stuff with that file. Organize it into a contingency table, calculate expected values, calculate percentage by rows, calculate so on and so forth, one step after another. When you're at home and you have more time, you can actually go through each one of those step by step and exercise your knowledge of SPSS in this. Okay, and in fact, there'll be a problem. We're going to put together a small homework for you. It'll be posted by tomorrow morning, and it'll have a problem like this. What's that?
I think I missed how you got
Odds ratio.
Where do you choose that?
Okay, it's a little bit. It's not. First of all, number one, when you got the table, I, I'm going to display something quickly while you guys are still working on that. I'm going to go back to Notepad here. I'm sorry. I can give you a little bit of help on that. Yeah, notebook. Here we go. One of the things that you may have noticed here, SPSS is a little bit weird that way. Let me show you what it looked like in SPSS when we did it with the previous example. If I can find SPSS, there it is. Okay, when we looked at the previous example, you may have noticed that, see this table here is kind of hard to interpret, right? This top number is the odds ratio. This second number is the relative risk, okay? Now, if you're not sure, how would you calculate it yourself given these numbers? Well, the way I would calculate the relative risk is 123 divided by 910 over 128 divided by 1078. And it's going to be one of these numbers. So you're going to know which one it is, right? And odds ratio is going to be 123 over 787 divided by 128 over 950. And it's going to be this number. So you can actually, if you get stuck and you don't remember, you can't interpret the way SPSS is describing it, you can nail down which one it is. And I'm about to show you something on Notebook.
So SPS doesn't tell you like it's this over that.
Yeah, it is. What it's saying is a description of it, but it's just not in the language that most of us speak. In other words, that on the left-hand side, that description is describing the odds ratio or the relative risk, but it's not quite in the same language that real people talk about. Now, just to give you a rough idea here, I'm gonna take a contingency table, and I'm gonna say this value is A, this value is B, this value is C, this value is D. And if I go across in the rows, this is A plus B is the sum. C plus D is the sum of people here. Okay, so my odds, my relative risk is equal to A divided by A plus B, right, over C divided by C plus D. Okay, my odds ratio is going to be equal to A over B divided by C over D. Okay, now we know we can when we bring a fraction up from the bottom, right? We can multiply it out instead. So it's the same thing as A times C over I'm sorry, A times D over B times C. Okay, that's the same
We went
thing.
over in lecture that like if it's C over D over A over B, correct?
I'm sorry, say it again.
For odds ratio, we went over in lecture that it's more or less arbitrary. We could if we want to play around with it so that the result is greater than one.
Right. Now, do you remember I did something interesting with the smoking? I made it so that the people that were smokers, even though they were originally 2 and 3, I made them 1. And I made the people that were non-smokers 2. I did that because SPSS literally puts the columns and the rows in alphabetically and numerically. So by making the smokers number 1, it made them the top row. And typically, usually you're expressing exposure because you think that exposure is going to cause more disease, right? So I fixed it so that the exposure was in the top row by making sure that it was the number 1 and the unexposed group was represented by the number 2.
Automatically going to do it where the top one
If it's that way, if the number is if the number that represents or the word or letter that represents the exposed group comes before the number or letter that represents the unexposed group, it'll put it in that order. If it doesn't, right, well, then you got a little bit of a problem because it's upside down. It still works, except you got to keep in mind how it works. Now, your relative risk and your odds ratio is unexposed to exposed. So, what would you expect if I told you that that if it were the top row were exposed and the bottom row were unexposed, then the relative risk is 2. If I reverse that and put the unexposed on top, 0.5, it'd be inverted exactly. And what does 0.5 tell you about the exposure or non-exposure? It tells you it's not just, innocuous, it's protective. If you get a relative risk or an odds ratio that's less than 1, it means that that exposure is protective. It helps protect you from that disease or outcome. Okay? And if you look closely at that box SPSS gave you, it actually does it both ways for the odds ratio. It does it with, it flips it over and you get the inverse. If you look further down that column, it'll give you the odds ratio from the perspective of exposed to non-exposed, and it'll give it to you again as non-exposed to exposed. So it really gives it to you both ways. Relative risk, I think it only gives you one way, but yes. Well, you have to think to yourself, which of these things, think for a second, which of these is an exposure, right? When you look at the variables, look at the names of the variables. Would you expect IV drug use or smoking to be an exposure or an outcome? It's kind of, you would probably reason that they were exposures and you should move them into the rows. The outcomes could be diabetes, could be cancer, could be asthma, could be HIV positive, could be, and so on and so forth. So yeah, once you learn the mechanics, SPSS, the mechanics are very simple. Analyze, for you're already starting at the same spot. Analyze, you go down to the test you want to use. In this case, everything we're doing today went analyze, descriptive statistics, crosstabs. Everything went to there, and then we had a box that we could choose our variables and what options to take and so on and so forth. It might take a little while to get comfortable with it. That's why I'm giving you this particular set for starters. Okay, so I'm going to go now and take a look at the set that we're just talking about. Yeah, guys have a few moments to work with it. Okay, so yes. Oh, what I did was here. Well, it's all I did there was it's just a mathematical trick, right? If I say, I'm upside down. Okay, if I say A over B divided by C over D, right? What I can do is I can take this, invert it, D over C, and multiply instead of dividing, right? So that's going to be equal to A times D over B times C. Just easier calculation. Okay, so now let's go back here to SPSS. I'm going to go to SPSS, and I'm going to open the document that we were talking about. I think I got it on here. Stenosis. Okay, stenosis. First column, smoker, yes or no. Disease, yes or no. Do I have the right one? I don't know if I got the one that I uploaded. Is that exactly the way the name is? Nope, this is the one. That's the one that's uploaded, right? Am I right? Yeah. Okay. This is smoker. Smoke, yes or no. Gender, male or female, and disease, yes or no. Disease being stenosis. Okay, so I'm going to go to analyze, descriptive statistics. I'm always starting from the same spot, crosstabs. Okay, for starters, I'm just going to look at chi-square for starters. Okay, so in the rows, I'm going to put the exposure. What do you think? Smoking for a good exposure? Okay, let's see if that's more likely to be to have aortic stenosis. Okay, I'm going to move that into my columns for my outcome, my disease outcome. So I'm going to go to statistics, and I'm going to click off just chi-square. That's it. I'm going to go into cells and click off observed and expected values. Just for the hell of it, I want to see them. You really don't need it to calculate chi-square. I'm going to click OK. SPSS creates it actually puts it into one table. Count is our observed values. Expected count is our expected values. Instead of putting it into two separate tables, it just drops everything into the same table. Gives our expected and our observed values. And our chi-square value, if we don't apply the continuity correction, the Yates correction, is 9.4. And with our continuity correction, it's a little lower, but it's still 8.6. Have we exceeded our critical value for chi-square of 1 degree of freedom? Yes. So our expectation is our two-sided significance, our p-value or significance is going to be less than 0.05. And is it? Yes, it is. So our null hypothesis was that there is no association between smoking and aortic stenosis. And our alternative hypothesis is that there is. So now we can reject our null hypothesis and accept our alternative that there is an association between the two of them. I'm going to do odds ratio and relative risk now. Analyze, descriptive statistics, cross tabs again, except this time I'm going to go into statistics, turn off chi-square, and turn on risk. Okay, I'm going to click continue. I'm going to go into cells, and I'm going to leave expected and observed. I'm also going to check percentages by rows. I'm going to click, actually, I'm going to turn off expected. We already saw it in the last time. I'm just going to check off observed and yeah, it's going to be all lonely. I'm going to check off percentages by rows. I'm going to click OK. Let's see what it gives me. Okay, so here we go. Smoking status. Of people that smoked, 54 out of 94 had stenosis, 57.4%. Of people that didn't smoke, 44 out of 121, or 36%, had stenosis. So I'm thinking my relative risk is 54 over 94 divided by 44 over 121, or 57% over 36%. Roughly, I guess, 1.2, 1.4, 1.5, right? If I look down here, here is my relative risk, 1.580. Okay, now if I look for my odds ratio, it would be 54 over 40 divided by 44 over 77. I'm going to do it with a calculator just for the hell of it. I'm going to clear everything out first, and I'm going to take the bottom part first because I can put that into memory. 44 divided by 77, right? C divided by D divided by 77. I'm only doing that first because I want that to be in memory. I'm going to put that into my memory. Clear. Clear. And 54 divided by 40. 54 divided by 40 is equal to 1.35. That's A divided by B, and I'm going to divide that by, recall memory, C divided by D, and that comes out to be 2.36. Here we go, 2.36. That's our odds ratio. Now I have to say, oh, fine, it looks to me like our odds ratio is 2.36 and our relative risk is 1.58. Can I reject my null hypothesis? Am I certain that those are really different than an odds ratio or a relative risk of 1? Well, I look at my confidence interval, and 1 is not within my confidence interval. So I can exclude 1 from my confidence interval and say that they are indeed different and reject my null hypothesis. And you would expect to be able to reject your null hypothesis because we just use the same data to apply the chi-square test. And in general, you should get the same result, right? Almost all the time, I would think. Okay, so that's how we would do that.
Can you select all of them at once?
Oh, you mean smoking and?
In terms of the balance, chi-square, odds ratio.
Oh yeah, you could do more. Yeah, matter of fact, let's turn everything on. Analyze, descriptive. I only do it because I'm trying to keep it looking clear and rational. Let's see, chi-square. The risk is already turned on. I don't think you're going to want anything else there. Cells, observed, expected, percentage by rows, percentage by columns, totals, you name it. You can turn all of this stuff on. And here, how's that for a mess? See, that's the reason why I tried to keep it a little bit simpler and clearer. Okay, there's your chi-square box, right? Same numbers we got before. There's your risk estimates, your odds ratio, and your relative risk, right? And your confidence intervals. So these two boxes really were what you were after as an endpoint. Right? Okay, So there'll be a relatively non-challenging homework, I hope. That'll give you a way to do it manually. No, one more beyond that. One more on it. I'm gonna keep it short. It's not gonna be a tremendous homework. It's not gonna be a lot of problems, but it's gonna be on odds ratio and chi-square. It's better that we break it up into two parts rather than, like pile everything together, even though it's an extra homework. So it'll be a relatively short one, and the last one will be the last two topics, which we're gonna start next week, and ANOVA, analysis of variance, and correlation. It'll be up by tomorrow morning, and you'll have a week. You'll have a week to do it. Oh, the project. I'll keep the homework simple. It's not the homework's going to be like you're going to be able to do it in a half hour, an hour. Homework. Okay, it's going to be a simple homework. Okay, the next one's going to be as simple a homework. And you want to know something, and you want to know something. All this complaining, you 3 minutes, 3 minutes on SPSS. If you spend a little bit of time on SPSS and learning it, 3 minutes on SPSS is going to give you 90% of your project, right? The rest of it's going to be a description of what the hell you did. When you know what you okay. Okay, we'll have plenty. We'll have some online sessions. We're going to have some online sessions on strictly on SPSS and how to use it. Okay? So it'll be recorded. You can always go back and watch it. And we'll have a number of short sessions, like 15-minute sessions. This is how you do this. This is how you do this. This is how you do this. So if you're going to work with chi-square, you know which one you can go back to and stuff like that. So we'll have shorter ones. Okay, good night, guys. Okay, so, and you guys online. Okay, take care, guys. Good night. There's booze over there on it. I'm getting the same thing online.